Hello everybody and welcome to another episode of the Daily Composites podcast. Martin, you looked shocked.
I am shocked. Daily? I thought it was monthly.
Has Gary not told you he wants one every day?
Every day, right. I think that's when we should introduce the AI podcast, I think.
That's a good idea. Hello everybody, welcome back. This is our festive edition, isn't it, Martin?
That's right, yes. Merry Christmas, everybody. And
Happy Christmas. Ahoy ahoy for Christmas.
And ahoy ahoy for Christmas from me.
I was going to say, yeah.
Ahoy ahoy from Christmas, for Christmas.
Yeah. And so today we're going to talk about the history of Fibreglass, or the history of GRP.
Yeah, the history of GRP.
Not quite the same thing, are they?
What prompted this was a student contacting us, just asking if we had any kind of a load of information for a course he was doing, and he was gathering a lot of information about composites and the history and the strengths and things like that. So I thought, they give us an idea. I thought, maybe we should cover the history of GRP in Fibreglass. Maybe on this one we'll cover Fibreglass. Maybe the next one we'll maybe do resins.
All right, okay. And so we haven't got any of our normal questions today, but if anybody does have any questions for future episodes, they can email us as usual at compositescast@gmail.com. With that said, let's get started and talk about the history of GRP. So first of all, Martin, what is GRP?
So GRP is an acronym for glass reinforced plastic. So it's basically a composite material made of a polymer matrix.
Yeah.
And examples of some polymer matrices would be thermoset plastics, polyester resins, vinyl ester resins. So if you take any of those resins and add glass fibre to them, that's glass reinforced plastic.
Right, and a composite is basically just where you put more than one thing together to make a new thing.
That's exactly it, yeah. So I mean, a composite could be anything. You could class bread as a composite.
Yeah, of course.
You mix different materials to then have a to form a whole different material at the end of it.
But I would not make a boat out of it.
No, definitely not.
Right.
Would feed the ducks.
Yeah.
Most people don't realise a lot. If you've had a filling at the dentist, everybody's walking around with a composite in their mouth. That's basically a composite as well.
Yeah.
But GRP, you can't confuse that with FRP. A lot of people think GRP and FRP is the same thing, but it's not. FRP can be is kind of it's a wider description. So you could put GRP in there, glass reinforced plastic.
Right, because the FRP. F stands for fibre. So it could be any sort of fibre that's reinforcing the plastic.
That's right, yeah. Right. So you've got Kevlar fibres, even flax fibres.
Yeah.
So that covers what basically composite GRP and FRP is. Which brings one to kind of like the first time kind of FRP was used. Well, the first time that we know of, because of how well it was preserved. But the ancient Egyptians, they used FRP, so they would use flax fibres to create bandages, and they would use resins, natural resins, or not the resins that we know. So it would be things like oils from, say pine or pistachio oils. Resins such as pine resins. Pistachio resins.
Yeah.
It's even been known they've found bitumen, traces of bitumen as well.
So what were they using the resins for?
So that would be things like mummifying bodies, preserving foods and things for them to take into the afterlife, because they believed that there was an afterlife, and you would take all these goods, all these foods, and even animals, pets were preserved as well in these resins. But then the flax fibres was obviously used to make the bandages.
Right, okay. All right, okay. Very good. And that, when you think about it, we've still got the same technology now, aren't we? We're using bandages.
Yeah.
Reinforced with, for example, what do you call it? Plaster.
Yeah, that's right, yeah.
So we're reinforcing bandage with plaster and hopefully not mummifying anybody, but making stuff anyway.
Yeah, that's right. Even resin as well. We've got our glass fibre bandage, woven bandage, and we use that with resins as well.
That's right, yeah.
and it's used a lot in wrapping as well. So when high spec, which then became East Coast Fibreglass, as we know it now, when we were a manufacturing site, we were known as high spec plastics. And Fred and Albert, who started the company, we've got a photo of one of the earliest projects they had, and that was wrapping a metal pipe with glass fibre bandage and resin.
Okay. And was that in the Egyptian times, or
quite possibly, mate?
Slightly more recent.
Yeah, slightly more recent.
In the 60s. Back in the 60s. Okay, so there was composites in ancient times, and resins, and bandages. But when did we start? Let's leap forward a few millennia, if we can, and get to the invention of glass fibres. Yeah,
so that this can go back to 1836. It was a Parisian craftsman who was known as Ignace de Bonnel. I don't know if I pronounced that correctly, but
sounds right to me.
That was his name. And he had the first patent. He created the glass threads, and that was interwoven with, I think it was silks and things.
Okay, right.
But the fiberglass was difficult to make thin and flexible. There was no reliable way to mass produce that.
I wonder how they do that now, because if you think of something like a what do you call it, matting, chopped strand matting, that is just strands of glass. That's tiny little pieces of glass.
Yeah.
But it's not brittle. It doesn't snap like glass would, like a pane of glass would, does it?
No.
And especially when it's in a glass fabric.
Yeah.
Is the glass somehow mixed with something else to make those fibres?
No, it is kind of.
Because glass fibre cloth is just like cloth.
Yeah.
That you would make clothes out of or anything, isn't it? It's just a similar sort of feel. It's flexible and.
I've been doing the research for all this. We've got the history down, but I've never actually. It's a good point you make there about it breaking. I don't know how to get around that.
Yeah.
I know that you can break fiberglass if you actually if you pull on fiberglass, it won't break. So if you take e-glass and kind of pull the strands, it won't break.
Right.
If you tie it in a knot and pull it tight, the glass will cut into itself and it'll snap.
I've seen that. Huh. Okay, so this guy Ignace.
Yeah. So
I remember reading about it a little while ago, and he managed to find a method of. I think he did it by one of those things that was discovered by accident. I can't quite remember, but he found a way of obviously heating the glass until it was heating whatever it is, sand or silica, whatever it is, till it's molten, and then drawing it out into a thin thread, and he was quite thin, Fred, wasn't he? Yeah. And drawing it out into a thread, and that's how he invented glass fibre. But as you say, couldn't do it at scale or make anything with it.
That's right. That's right. Yeah. Kind of leaping forward to 1880, and the person who had the first US patent for producing glass fibre, that was a Prussian guy called Hermann Hammersfer.
Right.
He was an American inventor, and he was the guy who actually mixed the interwoven the silk with the glass. That wasn't Ignace, but I got that wrong originally, but it was Hammersfer. Okay. And he was known as the grandfather of fibre optics and fiberglass. But it wasn't until 1893 when the Libby Glass Company got involved. They bought the patent. It was a guy called Edward Drummond Libby, and they purchased the patents from Hammersfer,
right?
And that's when things started to kind of move forward a bit.
All right.
In the technology, they actually made a dress out of fiberglass.
Right.
They're originally known for making the kind of spun lampshades out of fiberglass,
right?
And it wasn't until they were doing a show. It was a bit like the what's that American kind of big show where they used to bring loads of technology through.
Like a World's Fair type.
Yeah, it was a bit like a World's Fair. I can't remember the exact name for it.
Right, I've got it here. It was the Columbian Exhibition.
Yeah.
Exposition.
Yeah. And It was an actress called Georgia Kivan. She wanted a dress made out of this, and they actually displayed that dress, and it's still in the Libby Museum now. That same dress and the parasol as well. So that was the first kind of leap to kind of making something out of fiberglass. But there was a someone else wore the dress as well in the company, and it was very itchy, and the fibres would break and things like that.
So, timeline so far: 1836, Ignace Dubois Bonnell, patents glass threads. 1880, Herman Hammersfar, patents woven fabric.
Yeah.
1893, they had this thing at the Expo, and then into the 1930s. What's the next milestone?
So the 1930s, this gets closer to what we know and what we've seen of fiberglass today.
Yeah.
So if anybody knows Owens Cornings,
of course,
who produced a lot of fiberglass mats, so it was kind of their kind of history that brought fiberglass to where it is now.
Right.
And that was three guys known as Dale Kleist, Jack Thomas and James Slater. And it was James Slater who wanted to make this fiberglass so it would be made faster on a more of a commercial scale.
Yeah.
And it was I'm trying to remember which way around it was now. So James Slater, he was the guy who was pioneering it, and he brought the two guys on with him, who was Jack Thomas and Dale Kleist.
Yeah.
And it was by, like you were saying, it was totally by accident.
Okay.
They were trying to glue some blocks together, concrete blocks together.
Right.
And they must have been using the molten glass as an adhesive, I'm guessing.
Right, okay.
And it wasn't until they were spraying this glass they found these threads kind of as it cooled being produced.
Yeah.
So this was noticed by Jack Thomas. So it was actually Dale Kleist who was doing the process. Jack Thomas noticed it, and this is when they realised it could be adapted and enlarged to make commercial quantities of fiberglass.
Right.
And in 1938, the Owens in Illinois and Cornings Glass jointly created a new company, which was Owens Cornings.
Yeah, which is still going.
Yeah.
And they developed a mass production method for insulation, fiberglass insulation.
Yeah, so they would make fiberglass in different forms, so it would be woven and kind of a wool type. Yeah.
And leaping forward a little bit, I remember one of the things I learned about fiberglass is one of the useful properties for it when it really started mass production in the Second World War was its insulation properties, because it was like couldn't be seen by radar, I think.
Yeah, that's right.
Does that sound about right?
Yeah, combined with the resin as well.
Right.
So
because it's plastic.
Yeah.
Okay, so leaping forward a couple of years to the invention and patent of polyester resin.
That's right. Yeah.
Okay.
So I think there was some resins around, and there was another guy.
There's always been natural resins, hasn't there?
Yeah, that's right.
Rubber a resin?
I'm not sure if you would class it as a resin.
Me neither, actually. Anyway, yeah.
I mean, you get natural rubbers, but it doesn't.
It's like a resin that comes out of a tree, isn't it?
Kind of.
Rubber
Yeah,
comes out of
and
a
it
tree,
changes
so.
its formulation.
Yeah.
But another guy from that Owens Cornings was a guy called Ray Green. He made the first composite boat. But the resins at the time were pretty naff.
Right.
So he managed to make this boat, but he still wasn't quite happy with it. But it was around about when you mentioned the war there. During World War II, British intelligence agents stole secrets for polyester resin from the Germans, and they had kind of perfected it. And the British turned these secrets over to the American firm, and it was an American firm called the American Cyanamid Company.
Right.
And they produced the kind of forerunner of today's polyester resin, and that was in 1942.
Right.
So that kind of helped them build lighter weight planes and other equipment that would help them throughout the rest of the war.
Right.
It's funny how, actually, when you mentioned the war and how the Germans kind of invented a lot of materials and equipment that kind of help us out today. If you watch on Amazon Video, I can't remember the exact title, it's something like Hitler's stealth bomber.
Right, okay.
And when the British occupied Germany, they find this barn.
Yeah.
And in there is a stealth bomber that they have built. And when you look at it, it looks like the stealth bombers of the kind of late 80s, 90s.
Wow.
So they were just on the cusp of developing the first stealth bomber. And
and I think the Nazis also developed like ICBMs, didn't they? Rocketry, certainly, that was then nicked by the Americans after the war and ended up with them being first to land on the moon.
Yeah, that's
that was
right,
from a German invention of a rocket.
Yeah.
And I'm not sure even if weren't some of the nuclear things.
Yeah, did they not give some of the scientists pardons if they helped develop?
Yeah, something like that. I think they did. The rest is history.
The rest is history,
yeah. Okay, so all right, so into World War II and that stuff, and then what next?
So that's when, from then on after the war, and you'll, I think round about the 50s, fiberglass was used a lot. So a lot of things in the kind of 50s were starting to become kind of bubble shaped.
Right,
the cars,
that's right. Yeah,
remember all the cases for TVs and things. So as fiberglass was developed and became more commercial,
they just used it in everything.
Yeah, pretty much. Yeah, it was this brand new material that everyone was excited about.
Of course.
But we've still got things in our homes now that are made of fiberglass: baths, shower trays, all that kind of thing. A lot of caravans. Although saying that, a lot of caravans are starting to go to acrylics and things. The amount of phone calls I get on broken shower trays because they're made so cheaply with this thin acrylic.
That's right,
So fiberglass is still better than acrylic.
So where do you see fiberglass nowadays? I mean, I think of play equipment like slides in parks and like in soft play and stuff like that. They're all fiberglass, aren't they? Buses, boats, of course. Yeah, lots of different.
It's a really good material to disguise things as well.
Right.
So you can find a lot of kind of fake chimneys and things made out of fiberglass hiding telephone masts because everybody's paranoid about telephone masts.
Yeah.
Your 4G and 5G is going to mess with your head. They tend to try and hide them in things like fake chimneys.
That's a good idea, isn't it?
Yeah. It's used for climbing walls as well.
That's right. Yeah, we supply a few people, don't we, who do those.
Yeah, sculpting.
Well, I think we'll take a brief pause there, shall we, for a word from our sponsor, and we'll see you in 2 shakes of a lamb's tail. Hi, Nick here from ACF, dropping in quickly to tell you about a new product just listed on our website that's perfect for surfboard builders and indeed anyone working with composites, and it is Surf Pro Epoxy Resin. This system is designed specifically for creating durable, lightweight and crystal clear finishes on surfboards, kayaks and other watercraft. It's got excellent UV stability, so your projects stay looking sharp even after hours in the sun. Plus, it's easy to work with thanks to its low viscosity, making it ideal for laminating, filling and coating. So, whether you're a professional or just getting started, the Surf Pro Epoxy Resin System delivers professional grade results. You can check it out now at ecfiberglasssupplies.co.uk. Give it a try and see the difference for yourself. And now, back to the podcast. Welcome back. So, while you were listening to that 30-second advert, Martin fired up the internet and did a bit of research on the question we asked earlier, which was basically, how come little strands of glass don't just snap like glass does? So, crap. Away with you.
I couldn't find a definitive answer of why it does that.
Right.
But we know that glass is made from sand.
Right.
So to make the fiberglass, they take silica sand and mix it with limestone, soda ash and alumina.
Right. Okay.
And that's the perfect composition to make the fibres. So something in those materials must make it more flexible.
Right, because there's something firing off in my memory here, because I remember going to a glass blowing factory in Czechoslovakia, of all places, but they mix different coloured sands in with the normal sand that they melt down to make glass, don't they?
Yeah.
So if they're making coloured glass, that's obviously a mixture. It's not just glass.
Yeah, it's also something else in there. Yeah.
Sorry to interrupt, but I'm just thinking there must be lots of different recipes for glass.
Yeah, there must be. Yeah.
Yeah.
I mean, there has to be, because you've got your normal glass, which can break quite easily.
Yeah.
Then you've got the glass that's used in your windscreens that breaks into small.
That's right. Yeah.
I don't know enough about glass to go on about it, but then you have.
Did you know this?
Yeah, No, no, I didn't know. But yeah, go on.
Did you know that glass never fully sets, and it's just partially set? I know if you left it 1,000 years in your window, it would get thicker at the bottom and thinner at the top.
Really?
Apparently. It's an interesting fact. And it's like concrete never sets.
Right,
Concrete just keeps getting harder and harder and harder and harder.
Funny, some resins do that as well.
Ah, do they?
Yeah.
Okay.
And some become harder. You can kind of accelerate that by adding more heat.
Right.
More intense heat. Which is when they do a lot of carbon fibre panels, they do that in the ovens known as post-curing.
And that's similar with glass as well, isn't it? So it's not just I didn't research it, you did, and I'm sorry to keep interrupting, but it's probably the temperature that they're doing things at as well as the composition.
Yeah, I mean this material gets mixed together and goes in a furnace at 1,700 degrees C, which is over 3,000 Fahrenheit.
Right.
And this intense heat melts a mixture into a molten glass. And once it's molten, it's passed through a device called a bush. So if you imagine like a sieve,
right,
with loads of holes in, kind of like loads of little tubes, and that's it. Within that metal plate, the resin pours onto that, and then it comes out the other end in tiny strands out these holes. And as it comes out, it cools down rapidly, and that's what makes the strands. And then they do another process where they kind of they pull it out, so they kind of draw the fibres, and I think depending on how much force or how quick they draw it, it'll dictate the diameter of the fibres as well.
Okay, right, okay.
And they also apply a binder, what's known as sizing, to the fibres to stop them all kind of sticking together.
Right.
And that also enhances the bond as well between the fibres. And then once they've drawn all those filaments out, which are sometimes thinner than a human hair, the next thing is to put them into production. So after that, they'll either be left in really long strands to make woven fabrics, or they might be kind of chopped up to make the chopped fibres, which makes the chopped strand mattens. They're bound together using emulsion binder as well if you're using chopped strand matting.
And I seem to remember hearing in the past, and I should remind any listeners that there's only one expert in the room, and I just look after the website and stuff, but I seem to remember hearing in the past that the strands of glass in chopped strand mat are actually hollow. Is that right?
I think some are, yeah. And that's what, when you see a fibre of glass, it's white in colour, and then when you wet it out, it turns transparent. And I believe that's the resin kind of filling up the tube. Right.
So because that makes sense with what I was thinking next, which is when you get fibre optic cable. And if you ever see like a diagram of fibre optic cable, they just show two parallel lines and the light sort of bouncing along inside, don't they? So that must be a similar thing, a long glass strand that's hollow in the middle, so the light can't escape. So what we're doing, it's white because it's reflecting all, I'm just making this up, but it's reflecting all light. But if you fill that with resin and then you're consolidating it with your roller, then it's not hollow anymore, and the light, I guess, can't bounce around in it anymore. Ta-da!
Yeah, I'm not sure, but it sounds good.
It makes sense to me. That is all that matters.
We'll be running off the computer to do some further research now.
I know, yeah. We need another advert or a computer in here would be handy, wouldn't it? Right.
Yeah, so it's when it's put on, other than chopping it up into tiny chopped strands. It can also be put onto spools for making woven fabrics.
Yeah.
So if you go on our website, you'll see woven. You'll also see
different weaves of fiberglass.
Yeah, you'll see finer woven fabrics, which are used for surfboards.
Yeah,
and then there's the really thicker woven fabrics, which are used for kind of things like boat reinforcement.
Biaxials, triaxials.
Yeah, biaxials, triaxials. So the biaxials are stitched rather than woven together.
Woven, right? Okay.
And then you've got your combination mats, which could be any combination of either woven or biaxial, and that's stitched to a chopped strand.
Yeah.
When it's stitched to a chopped strand, it doesn't have any emulsion binders because it doesn't need it. It's already stitched to the actual product.
So you could use that with either polyester or epoxy?
Yeah, that's right. Yeah.
Right, okay.
Yeah. And what you'll find is with a thicker material, it's not necessarily a thicker strand of glass. There's just more strands on there. So when you see fabric sold at say 300 grams, and then you'll see a 600 gram material, that's its weight per square metre.
Right.
So the heavier the weight, the more strands it's got, which makes it heavier.
So it's got more strands, not bigger strands.
Yeah, that's right, yeah.
Okay, and those more strands will give you more strength.
That's right, yeah.
In your laminate. Right.
And then what's important is the orientation of the glass as well. So if you take a plain weave, you've got your 90 degree orientation of the glass.
Right, yeah.
Which is great for most projects. But let's say, for example, you were sheathing over timber planks. That 90 wouldn't be great for that because most of your strands running down the kind of join of the timber.
Yeah,
like it's going to be like the grain is going to be redundant.
Right.
Therefore, you would either have to kind of put it on skew if, or the best solution is use a biaxial fabric, which is instead of being 90, it's plus or minus 45 degrees, so it kind of crisscrosses all those joins.
Or I remember making a video with you that was about sheathing plywood, and I think you were doing a boat house, weren't you, off a boat?
Yeah, that's right. That was just chopped strand, yeah.
Yeah, I was going to say that used chopped strand, I guess, because that's in every direction, isn't it? So, so that doesn't matter.
Yeah, that's right. I mean, with that, if you're doing something like a plywood wheelhouse, the best thing to use would be epoxy, maybe biaxial, depending on the design. But on that video where we sheathed the boat wheelhouse, that was done on kind of a shoestring budget.
Yeah, that's
so that was showing,
isn't it? So
how we do it with cheap. Chopped strand.
Polyester resin's cheap.
That's
top
right.
coat's cheap.
Yeah.
So yeah, but still effective. And so what would be the difference between doing it the cheap way and doing it the expensive way? What would you gain from using epoxy and a different fabric?
Well, the expensive way is it's going to be better. One, because you would use epoxy for the cloth, and that gives you a better bond to the plywood.
Right.
If you ever bond 2 bits of plywood with epoxy and try and pull them apart, the plywood would break and not the actual epoxy laminate.
Right.
So it's a lot tougher than polyester resin, which you would use
stronger.
Chopped strand.
Okay. Better bond, rather.
That's right. Yeah. And also because you can use woven fabrics. Such as biaxial, which will crisscross any joins in the timbers if you've built a timber wheelhouse. It's a lighter weight as well. The resin consumption's a lot less. So whereas chopped strand will have a resin consumption of about 2.5 kilos to every 1 kilo of chopped strand, your cloth is near on 1 to 1.
Oh, okay. Right.
In reality, it's probably about 1.2 to 1. But if you go and buy textbook, it's 1 to 1.
Right.
Especially if you kind of, depending on the process, so if you squeegee it out and comb the resin through, your resin will go a lot further than just wetting it out by a brush. Right. Whereas with the chopped strand, you kind of have to use polyester resin to kind of break down the binder.
Yeah.
You can use powder bound mat with epoxy, but again, you kind of you've got more resin consumption, so there's no point. You may as well use the woven fabric.
Yeah, of course. And you wouldn't gain any strength or any structural advantage from using
Probably not now,
chalk mat. Okay. And just to finish off that section, if you were doing the expensive way, okay, so you're going to gain strength, you'll probably get a better finish as well, because you're not going to have that rough chop strand finish.
Exactly, yeah.
But what would your final finish be? Could you just leave the epoxy as is, or can you put some sort of
depending on the project, you can use it as is. A lot of people do that with plywood stitch and tape canoes and kayaks, although they do say with most epoxies, because they're not very UV stable. I mean, the strength wise they're quite good, but they'll kind of yellow off. They normally say cover it with a UV varnish.
Right. Okay.
Or you can just paint it if you want a certain colour. But to get a but the cloths, like you say, they're very fine, so they'll give you a nicer finish than chopped strand. And usually about another 2 or 3 coats of epoxy over the top will flood any kind of low points. Right. And you can sand it back and get a really nice finish.
So I guess that's another benefit, isn't it? Because you can't do that with polyester resins, can you? You can't just keep cutting more coats of polyester resin on.
I mean, you can do, but bearing in mind that the polyester resins chip quite easy, so you don't want too thick of a coat of polyester resin on top. You would normally, when you get at that stage, use something like what we did in the wheelhouse. We just use another coat of gel coat after a surface tissue, and then a flow coat to finish. But if you're doing chop strand, if you're doing a shoestring budget type project and you're sheathing, you wouldn't be trying to aim for a high cosmetic finish.
Right.
So if you're fiberglassing out an engine bay, something that's not going to be seen,
really matter,
or it's a workboat and you're not too bothered about the finish, then you would go chop strand polyester. But anything that's worth spending some money on and time on, and you want a decent finish, epoxy would be the best choice.
Brilliant. Well, we thought we'd run out of steam with the history of GLP.
It's a good job you asked that question.
It is a good job, because now I think we're a little bit over time. So I guess we'll wrap up and say Merry Christmas to everybody.
Yeah, Merry Christmas and a Happy New Year. And we'll see you all in 2025.
Oh my God, I'll see you next year. Bye.
Bye.